In the last video, I showed you an example of polymorphism in action. On screen is the code that used polymorphism. There are two lines in this code that are really important for you to understand. These are on lines 20 and 21. To make this discussion simpler, let's create a new class. I will call it NextMain. And what I want to do is copy those two lines of code from main to NextMain, and I'll just hard code the arguments in that call to get movie. I'll pass A for an adventure movie and Jaws as the title. Now let's talk about these two lines of code because there are several things happening here. First, I'm creating a variable with the movie type and I've called it movie. I then assign the result of this static method call, movie.getMovie, to that variable. This could have been done in several other ways. Let's use that method and try to assign it to an adventure variable, since we know that I'll really get an adventure movie if I call it this way. Adventure Jaws equals movie.getMovie, passing A and Jaws as the arguments. As you can see, this code doesn't compile. IntelliJ tells us that the required type is adventure and provided is movie. Why is this a problem? First of all, the compiler isn't going to run the code to figure out what will really happen. It has to be satisfied with making assumptions about the code based on how we wrote the code. In this case, I declared that the method getMovie is going to return a movie class. I didn't say it was going to return an instance of the adventure class. The compiler asked the question, can every kind of movie, which is the return type of this method, be called an adventure, meaning can every kind of movie be assigned to an adventure type? And here, the answer is no. The adventure reference, Jaws, would not be able to handle a comedy movie if that got returned, for example. That's because we can't say a comedy is an adventure. But I absolutely know that when I pass the letter A as the type, that I'll get an adventure movie back. But the compiler can't figure that out without executing code, and it's not going to do that. Now, I can give the compiler more detailed instructions to get around this issue. One way to do this is casting. Like casting with primitives, I can cast instances, so let's do that here. I'll cast the result of the movie.getMovie to an adventure type, and I'll also add the call to watch movie here, jaws.watchMovie. Okay, now this code compiles, and I can run it. And we can see that it runs just like it did in the two lines above these. But what happens if I make a mistake and I pass a C as the type? We know that doing that should give me a comedy movie. But let's not change anything else and just see what happens. I've told the compiler with this cast that I'm smarter than it is and to just leave this line alone. So this code compiles. But if I run it, I get a class cast exception. The message is pretty descriptive, informing us that the comedy class returned cannot be cast to the class adventure. This is a bad situation to have your code compile, but then get exceptions at runtime. Okay, maybe you're asking, when can you assign an object of one type to a reference with a different type? Well, first of all, you can assign any object to a reference that is of type object. I'll try that next. First, I'll revert that last change, and then I'll create a comedy instance, but assign it to an object reference object, comedy equals movie.getMovie, with the arguments C and airplane, comedy.watchMovie. I've created a variable called comedy, but I've set its type is object, and this code doesn't compile, but not on the first line where I'm doing the assignment, but on the second statement. Can you figure out why? The compiler won't use the method return type to figure out what comedy really is after you make this assignment. It just assumes it's an object, and this variable only has access to objects functionality. This is because, at any time in the code, an instance of object itself could be assigned to this variable, and the code has to work for whatever object gets assigned to this variable. This means that when you try to call a movie method on this object reference, you'll get an error. This is because the compiler can't locate that method, watchMovie, on the object class. Let's pause here a minute to add a method on each of the subclasses, and I'll make each method unique to the class. Going back to the adventure class, I'll add a simple method that's only on that class. Public void watchAdventure with no parameters. Indicate that we are watching an adventure. Let's copy that method. I'll paste it in the comedy class, and I'll change the name to watch comedy and then change the text to watching a comedy. And I'll repeat that for science fiction, so I'll paste that method in the science fiction class. Change the name and change the text this time, making it watching a science fiction thriller. Now let's get back to the code in the next main class. And if I try to run watch comedy on that object variable, I have the same problem that I had with watch movie. It doesn't see that method watch comedy on the object class, and it's not going to compile. Let's revert that back for the moment. Now, you could assign every instance to an object reference like this, but you wouldn't be able to do much with them without casting them to other typed references. In other words, to run watch movie on comedy, which has the type object, I'd have to cast it to the movie type. I'll cast the object reference to a movie reference, and then I'll execute watch movie on that new reference variable. Movie, comedy movie equals cast as a movie, comedy. What I want you to see by this is that using references that are too generic, like object, means you'll be doing a lot of casting. But even now, since I cast to a movie, check out what happens if I want to execute one of the methods I just added, watch comedy. This doesn't compile either. For the same reason I couldn't execute watch movie on an object reference, I can't run watch comedy on just a movie reference. The compiler will only look at the reference type to determine if that method is on that type, and watch comedy is not on the movie class. In this case, I'd need to actually cast to a more specific type, comedy. And let's do that. And now all of that works, so that's good. For good measure, let's try one other thing. var airplane equals movie.getMovie with C and airplane as arguments. Airplane.watchMovie. This code compiles, but here is something new. I haven't used this before, and you're probably asking, what does this var word mean? Well, var is a special contextual keyword in Java that lets our code take advantage of local variable type inference. By using var as the type, we're telling Java to figure out the compiled time type for us. Since the movie class was declared as the return type of the static method getMovie, then Java can infer that the type of this variable airplane should be a movie. You can see that in the hints if you've configured IntelliJ to show them. Now, why didn't it infer that it was a comedy class? Nothing about the signature of the method indicated that a comedy instance might be returned from the method, only that a movie would be. Okay, let's try another example of using type inference, this time by just assigning a new instance. var plain equals new comedy parentheses airplane plane.watch comedy. In this case, the compiler had an easier job to infer the type because I'm simply assigning a new instance of comedy to this variable plane. But you can see now that using this plane variable, I can execute methods specific to comedy without compiled time errors. Local variable type inference was introduced in Java 10. One of the benefits is to help with readability of code. Another is to reduce boilerplate code. We'll look at this feature in a lot more detail in the section on generics later in this course. It's called local variable type inference for a reason, because it can't be used in field declarations on a class, it can't be used in method signatures, either as a parameter type or a return type, it can't be used without an assignment because the type can't be inferred in that case. It can't be assigned a null literal, again, because a type can't be inferred in that case. Are you still confused about the difference between runtime and compile time typing? You can think of the compile time type as the declared type. This type is declared as a variable reference, a method return type, or a method parameter, for example. In the case of local variable type inference, LVTI, we don't explicitly declare a type for the compiled reference type. Instead, it gets inferred by the compiler, but the bytecode generated is the same as if we had declared the type. In many cases, the compiled time type is the declared type to the left of the assignment operator. What is returned on the right side of the assignment operator from whatever expression or method is executed sometimes can only be determined at runtime when the code is executing conditionally through the statements in the code. You can assign a runtime instance to a different compiled time type only if certain rules are followed. In this course, up to now, we've looked at only one rule that applies, and that's the inheritance rule. We can assign an instance to a variable of the same type, or a parent type, or a parent's parent type, including java.lang.object, the ultimate base class. Why are runtime types different than compile time types? Because of polymorphism. Polymorphism lets us write code once in a more generic fashion, like the code we started this lecture with. We saw that those 2 lines of code using a single compiled time type of movie actually supported 4 different runtime types. Each type was able to execute behaviour unique to the class. Okay, I hope that helped clear up some of the questions you might have had. I'm going to end this video here, and in the next video, I'll talk about different ways to test what the type of a runtime object really is. I'll see you in that next video.